Hi, my name is Perez Irizarry. I'm a civil engineering student from the University of Puerto Rico in Maya West. This summer I was working in the summer research opportunity program at the University of Michigan. During the summer I worked in the project titled The Punching Shear Behavior of Reinforced Concrete uh, Slab-Column Connection with Shear Stud Reinforcement. I was working under the guidance and mentorship of Dr. Gustavo Parra Montesinos, an associate professor of the Civil Engineering Department at the University of Michigan. As we can see in my poster, we have several tests in which we build the slab systems, and we can see right here where we can notice the flexure reinforcement and the shear stud reinforcement that was used for this test. Also here we see the test setup. We have a specimen placed on the hydraulic ram where we just test the specimens. What we are pretending to do with this research is that we want to study and evaluate the efficiency of the shear stud reinforcement to resist the punching shear failures, which occur commonly in flat plate slabs. If we go back to the poster, we could see the test that we performed. Here is the graph of nominal shear stress and the flexion of the column. Here we could see the peak point load in which the two curves of the slab and the column separates, that identifies that the punching has occurred in the test. Here we can notice the cracks, and you can see in the zoom out here the punching failure. As we can see, the studs in the center have this area particularly is very, very strong, so it creates some weak splines, and you have the failure that I just marked here. If we go here to this graph, we have some deflection profiles in which we could see how the slab deflected at the peak load in the different parts of the slab. Here we have the slab diagram, and we can see at the center of the slab, this is the curve that shows the deflection, and we can notice this little part here. That's the column. So as we can see, the column has deflected more than the actual curve of the slab, so that we can see the punching has still occurred there. The problem with this shear stud is that the building code allows a capacity that we can see here back at this graph that is a very high capacity, and when we actually test the specimen doesn't reach that capacity. So therefore it's very important to study these and see what's wrong with it, if there's something with the design, or to just see what really affects the behavior of this shear stud reinforcement. For the future work, we made two more specimens that were going to be tested, and we got some analysis from the yield line analysis. I was calculating the expected capacities to see how the specimen should behave, and we're going to be testing this following Friday. So I will have some pictures of the lab right here. I could show you that this is the lab that I was working on, and here's this old specimen that we're being used for another research. Here we could see the stats set up a little bit bigger. We can see that in here we have the markers. Those are used for the deflections and to register how the deflections are occurring, and we have a hydraulic ram to apply the load. Basically, um, this experience was very good for me. I learned a lot. It was a great experience. Totally recommend this program, and everyone here has made me feel like I'm comfortable and home. Like it's really a good place to be. You'll learn a lot, and you'll have some research experience, like really hands-on the material you really like too. Apart from that, I hope you like the research. It's just a little bit of what I was doing in the summer, and I hope you could decide to somewhere and apply to a program like this. It's really good, and I totally recommend it. So thanks for your attention, and that's it.